If numbers are small, then the best way to work out highest common factors of the numbers is just to list the factors. So for 6 and 8, here I've written the factors of each, and I've picked the highest one that is in both lists. So the highest common factor of 6 and 8 is 2. For the multiples, you just list the multiples until you can get to one that is common to both lists. Here's the multiples of 6, here's the multiples of 8. The lowest common multiple is therefore 24. If, however, the numbers are bigger, then there is a much better way, which I'll now explain. The method consists of prime factorising the two numbers. So for example, let's say I was working on 44 and 182, or let's say 180. Now try and do this mentally if you can. Just divide by 2 first, as many times as you can. So that's 2 times 22, 2 times 91, 2 times 50, 2 times 40. Keep dividing by 2 until you can't anymore, and then it's time to divide by 3. How do you know if you can divide by 3? Just add up the digits. If what you get when you add up the digits is divisible by 3, then the original number was, which means none of these are. 9 plus 1 is 10, that's not divisible by 3, so there's no point trying to divide 91 by 3. So just to get this video done quickly, I'll finish these prime factorizations for you. Now, to do the highest common factor, you make a multiplication question. That multiplication question should look like the two ones you've just created, but it should only use ingredients from both these shelves, I call them. I pretend they're kitchen shelves. So I see 2's on this shelf, 2's on this shelf, so use 2's. But how many times should you use the 2? Imagine you're trying to be selective, you're trying to make a really good meal, like high class fare. The posher a meal, the smaller it is, so only use it as few times as you can. I see a 2 twice, I see a 2 once, so just use it once. Highest common factor here, I see 2's on both lists, use them. I see 5's on both lists, use them. How many times do I see a 2 here? Twice. Here, 4 times, use it twice. Try to keep this meal as small as possible because it's high class fare in a posh restaurant. I see a 5 twice here, I see a 5 once here, use it once because that's the fewer of the 2 times. Now, lowest common multiple, imagine you're just making some mush and you're trying to make lots of it to make up for the fact that it doesn't taste very good. Here you use anything you can. So I see 2's, 7's, 11's and 13's. And here again I see 2's and 5's. This time you're trying to make it as big as possible to make up for the fact that you weren't very selective in your ingredients. Use everything as much as you can. I see a 2 twice here, once here, use it twice. I see a 7 once, use it once. I see an 11 once, use it once. I see a 13 once, use it once. I see a 2 twice here, 4 times here, use it 4 times. I see a 5 twice here. Oh, whoops, sorry, I already did the lowest common multiple. Lowest common multiple, sorry, I already did the highest common factor. Lowest common multiple, I see a 2 twice there, 4 times there, use it 4 times. I see a 5 twice there, once there, use it twice. Now, to get the highest common factor, you actually work these things out, so that's 20. And what I'm going to recommend you do now, even for horrible big questions, you try and do it as much as you can in your head, and the discipline that you should try to put on yourself is to only use the calculator once. So, in order to do that, muck around with order. That's a 10. That's a 10. And that's a 4, so it's 4 times 10 times 10, that's 400. Mucking around with the order is a really good way to do multiplication quickly. Now, in order to do this multiplication quickly, I'm just going to give you a little hot fact, which is 7 times 11 times 13 is 1001. 1001 is very easy to deal with. Basically, I see 4 times 1001, so the lowest common multiple has to be 4004. Now, in the exam, do not feel constrained to use the calculator just once, but I'm saying it's a good mental discipline because it forces you to think about smart ways of doing things by mucking around with the order of multiplication.